See, from yesterday's class onwards, we are discussing metals and non-metals. In yesterday's class, we discussed the physical properties. Okay, so in this class, we'll discuss the chemical properties. Okay, so the properties you have studied in previous class are physical properties. Though these properties are quite reliable, chemical properties are the better indicators of determining as whether the given material is metal or non-metal. Okay, so chemical properties are the um, better than physical. So in physical, we mentioned maybe, but here we can say exactly. Okay, so if these properties are possessed by any material, those are said to be metals and non-metals also. Okay, so first property is reaction with the oxygen. Okay, so chemical properties are better or better indicators. Okay, so better indicators of determining given material is metallic or not. Okay, so first property is reaction with the oxygen. Okay, with oxygen. So so to discuss this, I'm performing one activity. Okay, it is given in your lesson to know the reaction of oxygen with the metals and non-metals. Okay, so material required is one metal sample, that is magnesium, and one non-metal sample, that is sulfur. Okay, so spirit lamp and Bunsen burner, or a spirit lamp or Bunsen burner, and a litmus paper, etc. Okay, so we need these materials to perform this activity. So what is the aim of this activity? To know the reaction of oxygen, with the metals and non-metals. So take a small strip of magnesium and burn it. Okay, so collect the ashes of a magnesium in a test tube and add some distilled water to it. Okay, so test the solution with the red and blue litmus papers. Okay, what we are doing, we are taking a strip of magnesium. Okay, so here we are performing experiment on one metal and one non-metal. So metal is magnesium. Okay, so non-metal is sulfur. Okay, so we are burning a small strip of magnesium, and we are collecting these ashes in a test tube and add a few drops of water. Okay, add some water. So after adding water, try to check with the litmus paper. Okay, so the change in the litmus paper. So magnesium, it is a solid we are taking. Oxygen. Okay, so burning is nothing but burning takes place in the presence of air, right? Yes or no? So it is reacted with the oxygen present in the atmosphere. Magnesium oxides will be formed at the end. Okay, so this is also as added. This is in the form of a ashes. Okay, so take a small quantity of powdered sulfur in a deep deflagrated spoon and heat it on a spirit lamp. Now we are performing one another experiment, that is, so now take a powdered sulfur. Okay, in a test tube and try to heat it on a spirit lamp. As soon as starts burning, that sulfur starts burning, sulfur starts burning, introduce the spoon into a glass jar or tumbler. Okay, so try to place the burning sulfur in a glass jar or tumbler. Cover the tumbler with the lid. Okay, to ensure that the gas produced do not escape. Okay, so remove the spoon after some time, but try to keep the jar covered. Okay, so add again some amount of water to it. Okay, to the tumbler, and replace the lid. Shake the tumbler well. Okay, so what happens, what here we are doing, sulfur. Okay, so again here we are burning, right? Burning it takes place in the presence of oxygen. Here we get sulfur dioxide. Okay, sulfur dioxide. Okay, so solid, gas, again solid. So all the all the products in the above reactions, these two reactions are oxides, right? Magnesium oxide and sulfur dioxide. Okay, so the oxides of magnesium turns red litmus to blue. Okay, so we are testing, right? So it turns red litmus to blue litmus. Okay, so this is a change we can see after burning the magnesium strip after mixing it with the water. Okay, so magnesium oxide is a basic in nature. Okay, what is this? It's a basic in nature. Okay, basic. So what happens, these sulfur, okay, sulfur dioxide is acidic. Okay, sulfur dioxide is acidic. Here you we get a reverse, blue litmus to red litmus, it is acidic. Okay, so blue to red, acidic. So from this we can say that non-metals react with oxygen to give oxides which are oxides which are acidic in nature. Okay, so non-metals after reaction with the oxygen, what happens, non-metals react with the oxygen and to give oxides of oxides which are acidic. Okay, acidic, which are acidic. So metals, while metals react with the oxygen to give oxides that are basic in nature. Okay, so metals react with the oxygen to give oxides of basic in nature. Okay, so if the metals react with the oxygen, those gives a basic. Okay, those gives the oxides which are basic in nature. Okay, so but when the non-metals react with oxygen to give the oxides which are acidic in nature. Okay, these are the reaction. Magnesium plus oxide is equal to magnesium oxide, and sulfur plus oxygen gives rise to sulfur dioxide. Here in case of magnesium, that is a metals converts the red litmus to blue litmus, basic in nature, blue to red, acidic in nature. Okay, so this is a reaction with the oxygen. This is a given activity. Next, rusting of metals. Okay, so mostly you observe the rusting at your home for a iron object, right? Yes or no? If you place the iron objects outside, okay, so means outside means you can see moisture. Okay, early in the morning you can observe the moisture, and those reacts with the moisture and air. It is in the contact with moisture and air, so that it forms a rusting on a iron objects. Okay, so see, we already studied galvanization, right? What is galvanization? Iron object is coated with the zinc to protect from the rusting is called a galvanization. Okay, so these iron rods or iron materials are painted with the some kind of paint. Okay, suppose let us consider zinc. Okay, so what happens, these moisture and air in contact with iron now, no, this paint is covered, right? So By painting these iron rods and iron objects, we can protect this iron from the rusting. Okay, so in the same case, magnesium also becomes dull when it is exposed to air. Okay, the outer surface of the magnesium balls or more magnesium rods, it becomes a dull. But if you cut in a middle, you can see shiny surface. Okay, so initially the magnesium rods or strips are shiny. When they expose to air, what happens? They become dull. Okay, so silver objects and silver jewelry becomes black. You can see the your anklets and some of you wear silver chains, right? Try to observe those silver objects. Those becomes dirty and black. They become black color. Okay, so copper vessels become dull green. Okay, so if you have any vessels, old copper vessels, try to observe, they become dull green. Okay, so all these metals react with the components in air. Okay, so here what we are discussing here, rusting of metals. Okay, rusting of metals. Okay, so when they in contact with the air or moisture, air or moist air and moisture, see iron is in contact with the air, what happens? Iron becomes a rust. Okay, rust, iron rust. And what about magnesium? Magnesium becomes dull. Okay, so what happens for silver? Silver becomes black. Okay, and what about copper? Dull green. Okay, dull green. Okay, so these are the reactions. These are all our metals, right? These are reacted or exposed to the air or moisture, they become, in case of iron it becomes rust, and magnesium it becomes dull, and silver it becomes black, and copper dull green will appear. Okay, so see, all these metals react with the components in air. Okay, but gold does not become dull. See, try to observe silver anklets and that becomes dull, but gold does not become dull. Okay, does not become dull. Okay, dull. See, there are some metals which do not react or rust. Okay, those are what are those? Gold and platinum are the two metals which do not rust. If they are in contact with even hair, they will not become rust and they will not become dull. Okay, so those are platinum and gold. Okay, next properties, reaction with the water. Okay, reaction with water. See, mm, take a 500 ml beaker or a big glass. Okay, so and fill it off of it with water. Okay, so we are taking 500 ml. Okay, 500 ml jar. Okay, so off of the water, we filled it. Okay, so now mm, take a sodium. Okay, so you generally sodium is stored in a kerosene, because if it is stored in a room temperature it will catch a fire. Okay, so that's why sodium is stored in a kerosene. Okay, so take the sodium which is stored in a kerosene and keep it on a sheet of filter paper, so to bolt the kerosene, and cut a very small piece of sodium from it and put the sodium piece in a water using a forceps. Okay, so I'm placing a piece of sodium. Okay, sodium on a water, in water. Okay, so we already filled half of the 500 ml beaker with the water, right? So try to place the a small piece of sodium put on the water using forceps. The piece of sodium floats on the surface of the water with the hissing sound. Okay, so what happens is sodium, it makes hissing sound and floats. Okay, so makes a hissing sound and floats on a water. Okay, floats on water. Okay, so what happens, it makes this sound and floats on water. This shows that sodium is reacted extremely fast with the water, right? Okay, whenever we place the sodium strip on a water, it makes a hissing sound and it floats on a water. So this shows that sodium is reacting extremely fast with the water. Repeat the same experiment using a aluminum or iron. Okay, you will not see any changes even after 5 minutes. Okay, so because these metals react extremely slow with the water. Okay, so metals react extremely slow with the water. Okay, here sodium is non-metal, it is reacting very fastly, but metals react extremely slow with the water. Okay, so uh, this is a one indicator. Okay, so next reaction with the acids. Okay, so till now we studied about rusting. Okay, metals usually becomes rust or dull or black. they uh, they change their physical state. Okay, when they in contact with the air and moisture. Okay, so when they react with the water, metals react extremely slow with the water, but non-metals very fast. Okay, so next water, next reaction with oxygen also we studied. Okay, so now reaction with the acids. Okay, reaction with the acids. Okay, so how they react with the acids. Okay, so take a few samples of iron, zinc, copper, sulfur, aluminum, carbon, magnesium, iodine. Okay, so we have to perform all these testing for the different types of metals and non-metals. Okay, so here we are taking samples of iron, zinc, copper, sulfur, aluminum, carbon, magnesium and iodine. So in separate test tubes and add 5 ml of dilute hydrochloric acid to each of the test tube. Okay, so we are taking different test tubes. In that samples of iron, some amount of iron, zinc, copper, sulfur, aluminum, carbon, magnesium and iodine in separate test tubes, and we are adding dilute sulfuric acid, dilute hydrochloric acid to each of the test tubes with the help of a dropper. Okay, observe the reaction. If no reaction is found for 5 minutes, add 5 drops of concentrated hydrochloric acid. So now burn bring a burning matchstick near the mouth of the test tubes. You can observe the pop sound. This indicates the presence of hydrogen. Okay, so if the pop sound is coming, then the hydrogen is present. You found that some metals react with dilute hydrochloric acid. Okay, so liberating hydrogen, but non-metals usually do not react with the acids. Okay, so here we are performing testing with the dough by pouring. See, take a few samples of iron, zinc, copper, sulfur. Okay, so now in separate test tubes, in test tubes. So suppose say iron, zinc. So take a here I am taking zinc, iron, copper and sulfur in different test tubes and add dilute hydrochloric acid. Okay, chloric acid. Okay, so if the and after this, if there is no reaction found, what happens? Now try to pour a concentrated hydrochloric acid and bring a burning matchstick. Okay, if you bring burning matchsticks, if you bring burning matchstick, okay, burning matchstick, pop sound, you can listen pop sound. Okay, so this indicates the presence of a hydrogen. Okay, so you found that some metals react with a dilute hydrochloric acid. Okay, so liberating the hydrogen. Okay, some metals some metals react with hydrochloric acid react with hydrochloric acid and releases hydrogen. Okay, hydrogen, but non-metals usually do not react with the acids. Okay, so non-metals do not react with hydrogen. Okay, so these are the chemical properties. Okay, with the help of chemical properties, you can decide the given material is metal or non-metal easily than the chemical physical properties. Okay, so in next class we will discuss the reacting with other metals and as well as uses of metals and non-metals. Okay, so this is end of your lesson. Thank you.